Welcome to Arduino GUIs. When you Google Arduino GUIs, most of what you see looks outdated and boring. Yes, there are some tools out there, but they are either too complicated, not user-friendly, or demand heavy programming knowledge. But here's the good news. We have built a better way. Introducing Arduino GUI, the easiest way to create modern, sleek, and interactive GUIs for your Arduino projects. And the best part, we will be using Python, the world's most popular, beginner-friendly programming language. It is easy to learn, widely used in the industry, from robotics to AI, and perfect for creating GUIs. Just drag and drop and a little Python magic, you will be building professional designs in no time. Our learning journey is divided into 3 levels. The basic course. Here you will learn the fundamentals and build 3 starter projects: LED control, push button, and weather dashboard. In advance, you will level up your skills with practical projects like ultrasonic distance logger, home automation, volume control, servo positioning, object counter, data plotting, license plate recognition, saving data to a database, and more. In the Pro version, you will master Arduino GUIs with next level projects such as light intensity via hand gestures, robot car dashboard, water level monitor, face recognition door lock, smart waste sorting, virtual LED control, eye blink detector, and much more. The advanced and pro courses are currently available for pre-order at discounted prices, and the prices will increase soon within a few more days. So let's get started and discover how easily and fun it is to build modern GUIs with Python. So let's get started with our course. The first thing you have to do is you have to make sure you have everything installed properly. Now, most of this you probably have installed already, but if you haven't, then you can go ahead and go through this. Now, what we are doing here is, what is this page? This is basically within CV Zone, and what you can do is you can go to the description of this video, you will click on it, and it will take you to the course page. And in that course page, you will just log in and you will be able to get this. Now here we have the downloadable files, installations, and the video tutorial. Here in installations, we have all this information. Now, the first thing you have to install is Python. We are using Python 3.10, and this is the specific link. You can download this. If you have a later version, you can still use that too. Now, then you need an IDE for writing Python code. We will be using PyCharm, so it's up to you which one do you want to use. If you are comfortable with, for example, Visual Studio Code or something else, you can go ahead and use that too. But here's the link for PyCharm as well. Then the third thing is the Arduino IDE. Again, if you are working with Arduino, you already have installed this, but if you haven't, you can go ahead and install this. The last thing is our Arduino CV Zone library that will allow us to communicate serially. That can be downloaded from here. You will click on this, it will download the zip file, and all you have to do is you have to go to your Arduino IDE, and here you will go to Sketch and Include Library, and here you are going to add a zip library. So here you can simply click on cvzone.zip. And here you can see it's already installed, so it's asking me if you want to overwrite it. I will hit no, but in your case it will tell you to install it. So these are the 4 installations that we need. Once you are done with this, then we can go ahead to the next part. If you are facing any issues with these, make sure to comment below and I will try my best to reply if there are any specific versions or something like that. But most probably it should be fine and you can move on to the next part. So let's go ahead and get started with the projects. Okay, so now is the exciting part where we get started with our projects. Now, for any project that we will do, we are going to split it up into different parts. And pretty much each project will be 4 or 5 parts. And if it's more complicated, it might be more. So the first thing is that we need to understand the hardware. So the hardware, all the physical components, the sensor, Arduino, and all that. So once we complete the hardware, then we will have the Arduino part, the Arduino software, the Arduino IDE, where we will write the code for the sensors. And then we are going to develop our graphical interface using PyVisual. And this will be the third step. And the fourth step will be using Python. We are going to put it all together and make it run. Now, to get started, we are going to start with the LED example, which is the easiest one to get started. Now, in terms of wiring and hardware, we are going to only use an Arduino Uno. So if you can see here in the camera, there you go, you have the focus as well. So this is connected to my computer, and that's pretty much it. So this is the hardware that we have. Let me plug in. There you go, plugged out, plug in. Hardware done. So that's the basic idea of our hardware for this project, which is LED. Now, why exactly is that? Because pin number 13 already has a built-in LED. So what we can do is we can make use of that for our testing. When we click the button over here, it will turn on the LED pin number 13 here. So whatever graphical interface that we create. So that's the basic idea. So our hardware part is done. All good. So let's go to the next part. Okay, in the second part, what we have is the IDE Arduino code, Arduino IDE code. So how exactly does that work? We have already installed CV Zone, which we will be using to communicate. Now, if you haven't done that, you should go back and check the installation part. So we will go to File and we'll go to Examples and we will go to CV Zone. Here you have Get LED and Send Potentiometer. So we are working with LED, so we'll click on Get LED. Now this is a perfect gateway because here we have an example of how you can get the value of the LED. So here you can see we already have pin number 13 connected. It is an output, and then we are sending the value to it. So if we look at, actually let's copy the code and we will close this. And in our new sketch, we are going to paste this. So we are including our CV Zone library, and then we are creating an object, and we are saying that the number of values that you will receive is going to be 1, and digits per value will be 1 as well, because we will simply send 0 and 1 and it will turn on and off the LED light. So that's pretty much it. And then we have the total values. So this should be 1 as well because we are sending 1 value. And then we have the void setup. Here we are saying that our pin mode number 13 is an output because we are going to send it 1 or 0, high or low. And then we have to write serial data.begin so that we can start the communication process. Once that is done, we are going to get the values from Python, and then we are going to send it to our pin number. So whatever value we get at this number 0, we are going to send it to pin number 13, and pin number 12 we don't have, so we can remove that from here. So that's the basic idea. So this is pretty much the code for our project. So what we can do is we can upload this, and you can see it is done uploading. So we already have the code over here. And now in order to test this, it's very simple. All you have to do is you have to open up your serial monitor. And from here, you are going to write $, and then whatever value you want to send, 1 or 0, you can send it from here. So right now it's 0, so it's not on at this point. So if I send $1, it should turn on. Did it turn on? Yes, it turned on. There you go. Now you can see. And if I put $0 and then I hit enter, you can see the LED turns off. Then $1, it turns on. There you go. So that's the basic idea. So we can now externally control our Arduino using the serial commands. So what we will do is we are going to go ahead to our next part, which is designing the UI, and then from there we are going to go to the Python code. Now, in order to create our graphical interface, we have a lot of options, but we are going to use PyVisual because it's very simple and it's simply drag and drop, and it can sync with our project as well. So we are going to click on Start, And here we are going to go ahead and create a new project. And over here, we are going to call it LED. We will call it LED. And we will simply update UI because basically we are saving it. So we will click on save. So I'm having some internet issues. That's why we have some loading issues here and there. Anyways, moving on. Now we can create any graphical interface that we want. For example, we can go here and add, let's say, a button. We can make it on and off. We can put text inputs. We can send 1 and 0 from here as well. We have the browse button. We have drag and drop. We have lots of possibilities that we can do. But for now, what we need is simply a button that will allow us to turn our LED on and off. And in terms of design, we are going to update the design later on, and I will show you how to make it a little bit better. So now we will simply change this to on. We will write here on and off button. So this will be on for now. And we can rename this in terms of variable name. We can write here on off button. So that's our button name that we will use in our coding part. And then you have the color and all of these different options. We're not going to go into that for now, but later on we will look into that. So if we have just this, first of all, it's a good idea to save every now and then. So now it's saved. And now what we have to do is we have to link it to our computer. Now, what that will do is it will send everything here, the complete code, the assets, the fonts, everything to our computer without us having to copy. So for that, first of all, we need to create our Python environment, our Python project. So here we have a PyCharm that we have already installed, and we are using Python 3.10. And we are going to create a new project, Arduino GUI. So we will go ahead and create this project. So it is creating a virtual environment, and there you go. So now we have this. So what we will do is we will right click here, we will go to new, and we will create a new directory, and we will call it LED. So this is our LED project. So we have the LED directory. Now inside this, we are going to create, what should we add? Or we can directly use this. We can copy the path, the absolute path of this, and then we can go back to our project and we can click on link. Now here I can simply paste that absolute path. You can see it's now in LED, and then I can select this folder and I will click on allow, and now auto sync is enabled. If I update now, it will transfer all the files to our new project. So if we go back and if we open this up, you can see we already have all the files here. If I click on app.py and if I run it, it will not run it because we did not install PyVisual. So there are a few libraries that we need to install to get up and running. So I will name those over here so you can install them too. So here we will go to our command prompts and make sure you are in the virtual environment. So here you can see it's VENV, which means virtual environment. And over here you are going to install. So we will write here pip install, and whatever libraries we want, we can install here. So the first one will be PyVisual. The second one will be CVZone, because CVZone will allow us to communicate between Arduino and Python. So we have that serial communication, and it also requires PySerial for the serial communication as well. So CVZone is kind of a wrapper for that. So we need these three libraries to run this project. So we will simply hit install, and then we are going to wait for it to install. So now all the installations are done, and we can click on app.py and we can open it up, and there you go. So now we have PyVisual window and it says on, and we can click on this button and you can see the response. So that's pretty good. So now any changes that we make in our design, so for example, if I wanted to push it up and if I update it now, and while it's updating, I can go back and run it, and there you go. Now it's at the top. So any updates that we make from now onwards will be reflected as soon as we click on the update button. So that's pretty good for now. Now we are going to go to our final step, which is the fourth step, that we are going to control our LED using this graphical interface. So let's go to part 4. So now in step number 4, we are going to use our serial library to actually communicate between Arduino and our graphical interface. So in order to do that, we can import it from CVZone. So from cvzone.serial module import serial object. And what we can do is we can simply create our object over here. And let's just call it Arduino for now. Arduino equals serial object. That's pretty much it. Now, if you wanted to give an exact port number, you can give that too. You can give the baud rate, you can give the digits, maximum tries, and all that. But for now, we have everything on default. We have only one digit. Our baud rate is already 9600, and our port number is by default, whatever Arduino we have, it will use that. So for example, here, if we go to click on here, we see there's only one Arduino here, and the COM port is 7. So it will find that COM port by default, and it will connect to that Arduino. So we don't have to do that. So once that is done, now what we need to do is once we press the button, we need to toggle it on and off. So how exactly can we do that? So in order to do this, it's very simple. First of all, we have to check for the on release button or on click button function. So where exactly is our button? How can we access it? So if we look here, we have an object, you can say a dictionary by the name UI, and everything is inside this UI. So what we will do is we will write here UI. Inside that, how many pages do we have? If we click on here, we have only one page. So this is page number 0. So we are saying that on page underscore 0, we have a button. So what is the name of the button that we added? So if we go back, and here is the variable name, you can see it's on off button. Now you can also verify that. I'm not sure if you can see that. Yeah, over here you can see we have this button. If you click on this, you will see the code generated. So here, if you go to page UI page 0, you can see the name of the button is on off button, right? So this is how you can access this. So you can simply write, I am talking about on underscore off underscore button. If you don't give this name, by default, it will give it a name button underscore 0 or something like that. Okay, so now what we need to access is the functionality of this, that dot on click. Whenever it's clicked, we need to initiate a function. So we need to give it a function that it runs. So we can say that function is, let's say, toggle switch, right? That's the function. And we'll just put pass, or we can write here print hello, right? Just hello. So here we are going to give in the name of the toggle switch function. So if we run this now, our access is denied. Why our access is denied? Because here we have opened the serial monitor. We need to close this because Arduino is trying to, this IDE is trying to access it. So we will close that and we will run it again. And there you go. So our Arduino Uno at COM7 is connected. And if we click on this, it says takes 0 positional argument, but 1 was given. Okay, we need to add an argument here, any argument. So we can write underscore as well. And then we can simply run it. So it needs some argument in there. So if we click on that, it will say hello. There you go. So that's how simple it is. So now what we need to do is we need to send in, if we send in this UI over here, then we will be able to access everything within this function. And then we can say, do this, do that, whatever we want, we can do that, right? The other way is that we can simply, right now, what it's doing is it's sending this button over here itself. So we can write here button and we can print this button. So if we run this now and we click here, and there you go. This is the PV button, the Pi visual button. And now we can simply access its properties, right? So if I wanted to change its color, if I wanted to do something related to it, I can simply write button dot do something, right? So that's the idea. So if I can write button dot text equals no. So if I run that, and if I click on it, and there you go, it says no, right? So that's how simple it is. So now what we need to do is when we click on this button, we need to send the value of 1 so that the LED turns on. So how can we send the value of this 1? So we will simply write Arduino dot send data. This Arduino is basically this Arduino dot send data, and inside we are going to send 1, right? So if we send 1, it will turn it on. So if we run this now, and this is our Arduino. I'm not sure if you're able to see this. There you go. You're able to see it now. And if I click on it, and there you go, it turns on, right? It says no as well, but it turns on, right? So we can right here say off. So as you can see how simple it is to get started, right? So it's very, very simple. You can simply send the data 1 and it turns on. But now the question is, what if I wanted to turn it off as well? And what if I wanted to toggle between that? So what we can do is we can create a new object, a new variable, and we can write here toggle underscore state, right? So by default, we will say it's false. And then we can access it here by writing global, what was the name? Toggle state, and then based on this toggle state, if toggle states, then do this, else do this, right? So one of them will be off, the other one will be on. So here it's on. So if toggle is already on, it should turn it off and it should send a 0, and if it's not, then it should turn it on and then it should send a 1. Yeah, I think that should work. So if we run this now, and here we have our Arduino, and if we press on, did it turn on? I can't see from here. Let me put it here. There you go. And if we turn it on, nothing happened. Nothing is happening. Let me check why. Global toggle states. Oh yeah, we are not changing the state itself. My bad. So right now it's false. We didn't actually put it true. So this here, it was true. So we'll make it false. And this here, it was false. So we'll make it true. There you go. So now we should be able to run it. And if I turn it on, there you go. It turns on. Are you able to see this? There you go. There you go. So turns on, and then off, then on, then off. Now, if you wanted to write different text, you can write, so like you can switch between on and off. Some people prefer when it's on, it should display off, and it should be off when it's on, vice versa. It depends on your taste. Now, if you wanted to change the color, you can do that too. So for example, in off state, let's check the color, what it is right now, and then in the off state, we can change it. So if we go to UI and UI page 0, and here we can see we have all the options that we can change. So here we have idle color, and that's our idle color, right? So we can copy that, and we will come here and we will say button dot idle color equals this. So this is when it will show off, and this is when it will show on. So with on, we will keep it the same, with off, let's say we will change it slightly, right? So we'll make it 100, and we will make it, let's say 100, and let's say 200, right? A slight change to show difference. So if I click on it now, there you go, off, on, off, on. I think the first time it didn't change properly, because it might not be in the state, or maybe we need to flip it. Let's put this one here. Let's put this one here. So if you click on that, yeah, there you go. So on, off. So now the text is reversed, so we need to check that. So again, it depends on you whether you want to keep it on and off based on that. And here you can change the color as well. So if I want to, I can put 0 here, and it will completely change the color. So it's simply RGB. So there you go, on and off. So there you go. And by default, it is actually true, and it shows on, right? So that's why it's giving us that problem. So if we click on this now, there you go, it goes off and on, off and on. Is it changing the color? Yeah. Is it turning on and off? Yes. So that's pretty much the idea of this project. Now if you wanted to make it a little bit nicer, now we are going to go ahead and do that. So the code will pretty much remain the same. We might add a little bit visibility on and off or something like that, but the basic code, the essence of it, will remain the same. So that's the basic idea of how you can do this. So in the next part, we are going to create a better UI and see how that turns out. So now we are going to update our design to make it a little bit more pleasing. And what we will do is we are going to create a lamp, and we will turn on and off the light of that lamp once we do that. So it will reflect over here as well, and it will reflect in the Arduino. So what we will do is we'll create a new project, and we are going to call it LED lamp. And we are going to add some images to this. So we will simply paste them here. Open that up. So you will have these images in the downloads folder, so you can simply download from there. So here we have the lamp and the lights. So let's make capital light and the lamp. So this is a basic lamp. We will have that image here, and then this is basically a whitish light, so something like this. So once we turn it on, it will show this. So using these, we are going to create our design. So let's copy the link of this, the path, and then we will go back to our design. And here I have created a new project by the name LED lamp. Very simple. And then we are going to go ahead and take advantage of our upload button. We are going to click on upload image, and then we are going to go ahead and upload these images. So we will upload the lamp, and we are also going to upload the lights. So now before we use these, let's make the window a little bit smaller. Let's make it let's say 300 by 400, I believe, or 300 by 300 is not bad. Like, okay, let's make it 400. And once that is done, you can press the fit button to actually fit the image again, the window again. So that's our background, and let's make the background itself a bit dark, something blackish grayish, something like that. And now we can add our lamp. So this is our lamp. We can make it a little bit bigger, but it should not be blurry. We can put it over here, and then we can add our lights. This is our lights. There you go. And we can push it a little bit backwards. There you go. So once we turn it on, it should be something like this, right? So I mean, that looks good. So we need to turn it on and off. And let's add a button for this. Or what we can do is we can use an icon as well to turn it on and off, and we can change the color of that icon. So we'll go to graphics, we'll go to icons, and here we can write, let's say, on, maybe this. Yeah, there you go. So here then we can decide what color should it be when it's on and when it's off. So let's say for now we'll keep it like this, and there you go. I mean, I would say that's a good design, right? So it's very simple, and we only have like 3 elements, and that's pretty much it. So now what we need to do is, if we are changing something, we need to write the name for it. We need to give it a variable name. So here, this is our light. So we will write here, let's say light. And then here is our on off button, right? So that's our button. And yeah, that's pretty much it. So we are going to save it. And once we save it, we are going to link it. So we will go back to LED lamp, and we will select the folder, and we will allow auto sync is enabled, and then we will download all the files. So we will give it permission to save. And if we go back, this is our LED lamp now. And if we click on app.py and we run this, there we have our window, right? So I mean, come on, that design is, I mean, that's good, right? You have to accept that, right? Anyway, so now we need to add the what do you call, the coding part. So here we have the LED app.py, and then here we have the app.py for LED lamp. So we will just copy paste pretty much all of it, and then we will use it there. So the attach events and the toggle switch we are going to copy, and the attach events and the toggle we will put it here. Okay, I think that should be good. But now of course we have changed the name. So on off button is pretty much the same. It will toggle and it will change the color. So let's run that, and if I click on that, you can see the color is changing based on what we require. And now if we look at this is pretty much running the same way, right? So that's good. So we can make it green when it's on, and then we can do the other thing. So by default we will turn it off, so we'll put it as false. And then the button color, when it is on, it will make it off, so we will put it as 255 255. We're basically making it white. 25, or what is the color by default? So if we go to UI page 0, the light, the image, the on off button, this is the idle color. So let's copy that. So we'll keep the idle color as it is, and then when it's on, we are going to make it green. So RGB. So this should be, let's say, 100. This should be 180, and let's say this is 100. Okay, so if we run this now, and if we go here, now it becomes green, and now it becomes white. So I mean, that's pretty good. So then one last thing we have to do is we have to turn on and off the light. So by default, we can write here that UI page 0 dot this is light dot is visible. Now you might be wondering, where exactly am I getting all these values from? So you can simply go to UI page 0 and you can check whatever options you have here. You can on click, on release, is visible, and so on. So basically, if you go to lights, you can see you have is visible. You can also play with opacity as well, so it will give you the same effect. Is visible will be false by default. So if we run this, now the light is not showing. but then once we click on it, it should show. Now, here is the thing. We are able to access is visible of our light because we have UI within this function. You can see, oh, where did it go? So here you can see this UI is present in this function. That's why we are able to access it. But here we don't have this UI. So we need to add that. So how can we add that? So we will write here from function tools, imports, partial, imports, partial. Oh, from is wrong. From functional tools, import partial. And then what we can do is, instead of just sending in toggle switch, we are also going to send in the UI as an input. So we will write here UI equals UI. And we will write here partial. There you go. So this is the name of the function, and then this is the variable we are passing. So over here, we need to write dash UI, and that's it. So now you will be able to access everything within UI. So here, for example, I can write, I can copy is visible parts, and here I can write when the state is on and we're making it off, it should be false. And then in this case, it should be true. So we can write here true. And now if we go back, and there you go. So that's how easy it is to build this. And as you can see in Arduino as well, we are getting our response. There you go. We're turning it on, we're turning it off. Let me zoom that in. There you go. Let me make myself a little bit bigger so you guys can see. There you go. Put it on one side, and we'll put this on one side. So here you'll be able to focus here. There you go. So, oh, yeah, there you go. If I click on this, it turns on. If I click again, it turns off, on, off, on, off. And this is using Arduino and Python graphical interface. So that's pretty easy to do, and that is how we can create this project. So as you can see, the code is pretty much the same what we did before. It's just that we introduced a few more images, a few more variables, and that's pretty much it. So but it amplifies the design, the modernism of it. It's just much better than what we had as a simple button before. So this is pretty much it for this project, and let's move on to the next one. So let's go through the hardware first. Here we have an Arduino Uno, and then we have a breadboard, and on the breadboard we have a push button. Here you can see we can simply press the button. Then we also have a pull-up resistor. You can use a lot of different values. The most common one is around 10K. So now let's discuss where exactly is the wiring going and how does it work. So here you can see we have the 5 volts and the ground. So these two wires are 5 volts and ground. They are going directly to our breadboard supply. So the red one is 5 volts, the blue one is ground. And then these signals, they are being transferred to the resistor and the button. So here you can see the red one, the positive, is basically going to the push button. So one side of the push button is positive, and the other side of the push button, on the other hand side, that goes to your signal. So here you can see this is 8, pin number 8, and then the other side of the resistor is connected to your ground, and the other side of that resistor is connected to your push button. So the diagram of course will be shared as well. You can follow that too, but it's a very simple setup of how you can use a push button, any type of push button to connect, and then you can create the UI for this. So let's go ahead and go to the Arduino code now. Let's have a look at the Arduino code first. First of all, we have the include CVZone library. Then we have the serial data object that will allow us to communicate. And then we have to tell how many values are we sending. So we are creating an array and we are mentioning how many values are we sending. Now, normally you have to put at least 2 to make it work properly. So if you, even if you're sending 1, you should still put 2 because we have an issue with that. We will fix it later on. But for now, you should just use 2 as a default. Now, then we have the push button. So if you remember, we connected it to pin number 8. So that's why we are writing 8 here as our push button. And then in the void setup, we are mentioning that that pin push button is basically an input. And we are also initializing our serial begin, which is at the baud rate of 9600. And it is basically from here. Then what we are doing is we are getting that button state, we are digitally reading it, and then we are sending it by saving it here. Whatever values we want to send, we declared them here as an array, and we are saying the first element of that array should be the button state, and then we are sending that data outside wherever it wants. We are sending it serially, and then we are giving a small delay. So that's pretty much it. So if we run this now, we need to test it whether it's working or not before we can go on to the Python part. So once we run it, we have selected our COM7 and we are going to test it using the serial monitor. If we open up our serial monitor, you can see here we are getting 2 values, 0 and 0. So if we look at the output now, right now it's 0. If I press the button, it should become 1. There you go. It becomes 1. If I release it, there you go. It becomes 0. If I press it again, there you go. It becomes 1. So that's the basic idea of how you can basically get the input value transferred serially. And now we can simply go ahead to our Python code and get it from there. But before we do that, we need to create the UI. So let's go ahead and do that. Now, in order to create the UI, we'll go to PyVisual, and here we are going to rename our project. It's a new project. We are going to call it, let's say, button, or let's say push button. Now, one thing we can do is very simple. We can simply go here and we can add a button here and change its state, or better yet, we can add some graphics and we can change the color of that once we click on our actual button. Now that is all good, and that is something straightforward. But what I was thinking is that why don't we create the actual graphics of that button and we make it go up and down? So it's like we're pressing the button, right? So if we go here and we write Arduino push button side view, and we go to images, and there you go. So here you can see this is our push button, and this is the kind of side view that we are getting. So why don't we copy this design and try to replicate that, right? So that will be fun, right? Something like this maybe, or something a little bit less complicated, maybe something like this. So let's go ahead and try that. So in order to create something like this, we can go to PyVisual, very simple, and we are going to create a rectangle. So here we'll simply create a rectangle. Maybe this is too much. We'll make it a little bit smaller, and we will center it, and we will make this black, full black. There you go. And if we go back, then we have a little bit of white or something like gray at the top. So let's copy this, make it a little bit smaller, and then we can make it let's say grayish, something like that, and then we can push it up like that. Yeah, and maybe a little bit down. Yeah, that makes more. No, that doesn't look good. Okay, anyways, it's at the corner, and then we have these gray parts, and then we have this button inside this button. Yeah, these black parts. So we can copy this again, we can make it smaller, and something of that sort, and then we can put it here. Maybe it's a little bit wider. Yeah, something like this, and then we can push it back. Maybe the corner radius is too much. Maybe let's reduce that and maybe make it a little bit smaller. Yeah, that makes sense. We can copy this and we can paste it on the other side, and we can push it back also. There you go. Yeah, that looks good. So let's just make sure that they are at the same distance. Right now we don't have the functionality of going to the exact distance, so what we can do, we don't have reference lines, so we can make this 0 0, and now we can create a box, and using that we can decide where to place it. So it's a little bit, so if I move this at the edge, and then I will place it here, then I will place this at the edge somewhere here, and then I will place it on the edge here. There you go. So now I know both of them are in the right position. Okay, that being said, let's move on to the next part. This is our main button. So again, it's the black thing here, right in the center, and we can push it back. There you go. I mean, come on. That looks like a button. That already looks good, right? And we can even add a little bit of shine, you know, maybe something like this. Like, I'm not a designer per se, but we can try. So let's reduce the corner radius and make it like white. Yeah, might look good. So let's make this white-ish, maybe a little bit thinner. What's the width? It's 10. Let's reduce it to let's reduce that to 5. Nah, it doesn't look like something shiny, you know, or like a reflection. Maybe here. Nah, I don't like it. Never mind. We'll move on to the legs. The legs, we can simply make them from this gray. I guess it's kind of silver, so probably the same color. Yeah, so we can center it here, and we can make it a little bit smaller and longer, something of that sort. Copy this, and we can paste it here. There you go. So now we can send it back and send it back. There you go. So that's pretty good. I mean, looks like a button. Now, before we go any further, let's just save it. So now let's go ahead and link this so that we can open it up in Python and make some changes. So here we have our Arduino GUI project. We can create a new folder and call it push button. And then we can select this folder and allow, and then we can update, save changes, and hopefully that will be transferred. So let's open that up. So there we have it, push button and app.py. So looks good so far. Let's run it and see if it will work. And there we have it. That looks pretty good. Okay, so now that we have this done, let's move on to the next part, which is writing the Python code and make it and making it work. So the idea is when we push the button, this button part here should go down. So that's pretty much it. So let's go ahead and do that. So now we are going to go ahead and write our Python code so that everything works together, and we have our button running. Whenever we push the button on Arduino, it should reflect in our UI. So basically what happens is opposite of what we did in our LED part. In the LED part, we were the ones sending the command to Arduino. Now Arduino is sending the command to us so that we update in our UI. So we need to keep checking whether something has updated in Arduino or not. So now in order to do that, first of all, we need the CV zone library and we need the serial object like we have done before in our previous part. And then of course we need to create a serial object from it, and we usually like to call it Arduino. Now the COM port and everything else remains the same because we are using by default. If you were changing it, you can change it here as well. Okay, now the difference here, we need to understand the difference here. In the LED example, in the app.py, if we wanted to send the command, it's very simple. You write Arduino.send data. That's it. No while loop, no looping, nothing. But in this case, we are receiving the value, right? We are receiving it from Arduino, and we need to constantly keep checking whether we are getting something or not. So in order for that to happen, we need to add a while loop. And that while loop needs to be in a separate thread so that it doesn't interfere with the UI. Okay, sounds a bit complicated, but it's very simple. Let me show you what it means. Okay, so first of all, we need to make sure that we are getting all the information from Arduino. Once we get the information, what to do next, we will look into that later on. So as always, we will always start from attach events. So in attach events, we are going to create a function which we need to run again and again to get the data. Now, in order to get the data, all we have to do is we have to write this command. My data equals arduino.getData, right? But again, as I mentioned before, this will only get it once. We need to loop it so that it gets it again and again. So how can we do that? We can add a while loop. We can simply write here while true, keep getting that. But sometimes it ignores or something wrong happens. There is a malfunction, there's an error, something happens and it doesn't get, so it should not break everything. Instead, it should keep moving forward. So we will add try and accept. So try to do this. If you're not able to, accept and then pass, right? So that's the basic idea, that if you are able to do that, do this, and then it will keep giving us the information. So if we run this now, let's try to run it. Let's print my data. So if we run this now, and the permission is denied because we have our serial monitor opened here. As always, we have to close it and then we can run it again, and there you go. So right now we are getting 0 0, and if I click on the button here, you can see, let me open up the camera, there you go. So if I push the button, you can see it becomes 1 and 0 and so on. So that is good, but the problem here is, again, when we are talking about the UI itself, it will get lagged, right? So if you look here, the UI doesn't appear at all. It's not even showing because it's running in this loop and it's never exiting to the next part. So what we need to do is we need to create a function out of this and we need to push it in a separate thread. So how can we do that? It's very simple. We are going to call this function pooling Arduino, and basically this is our function, and we'll push all of this inside this. And now what we can do is we can create a thread and then start this pooling Arduino function in a separate thread, right? And it should be not interfering with the UI, right? So that's the basic idea. So what we can do is we can write here thread. We need to import threading. So we are going to import threading. Simple as that. And then here we can write thread equals threading dot thread. And then the target is pool Arduino. So we have here pooling. We can write the same spelling, pool Arduino. And then the daemon is true. So daemon basically the idea is that whenever the process or the main app stops, should this process stop or not? Like for example, if I were saving a file, even if the app is closed, it should not close this process until it finishes saving the file, right? In that case, you would put it false. But because our idea or our function is not like this, it's basically giving us values constantly. So whenever we stop our main function, main file or main app, this should stop as well right away. So that's why we are putting daemon as true. And then all we need to do is we need to start the thread. So we will write thread.start. So that's the basic idea. So now this part here is completed. And if we run this now, it will run on a separate thread. And there you go. So now our UI is visible. And as you can see at the bottom here, we are receiving the values as well. But if I press the button, the values at the background change. But in reality, this function or this image here does not change. So we need to change that. So how exactly can we change it? It's very simple. All you have to do is you have to change the height of this, right? So you can say reduce the height, make it smaller. So this is a rectangle and we need to change the size of that. That's it. Now, how can we do that? So if you look at what I did, I closed the program and this also closed. If I put daemon as false, this will not be the case. It will first try to complete this process and then finish. So it will be an infinite loop. So try not to do that. Okay, so how exactly can we make the size smaller? We will go to our UI and this is the only thing that we need to change, right? So we will give it a name. So we will, let's call it button rect. You can call it whatever you want and we can save it. So now we can access this as button rect. So instead of printing the data, whenever we get the data, we are going to call a function to change the height of this. And the height will be depending on whether the button is on or whether it's off, right? So we can call this function toggle underscore UI and we will write here pass for now, right? And by default it will it get something? Okay, we'll look into that. For now we will just call this function toggle UI and then we can send in our data, right? So whatever data we are getting, we can send it here. So we can write here my data and we will get our data here, or we can simply write data like that and we can print data. So now we should get it over there. So let's run that. And if we see here, you can see we have the print. Now, other than that, we also need the UI. So we need to send in my data and we also need to send in UI. So here we will receive UI as well because we need to change the height of it. So we need to add it here. So let's run that and everything is looking good so far. So now what we can do is once we get the data, we need to parse it. So if you look here, this is our value and this is in strings. We need to convert it into integers. So we can say our, let's say state equals our data at number 0 and then we need to convert it into integer. There you go. So now if I print this, I will simply get the value, the state value. And let's remove the data. And if I run this now, there you go. I'm getting 0. If I press the button, I'm getting 1. 0, 1, 0. There you go. So that's the basic idea of how you can do this. Now, once we have the state, now we can decide what to do with the state. So if state equals 1, then we do something else. We do something else, right? So that's the basic idea. So we need to define what happens. So now what we can do is we can change the height of our rectangle, right? So we will say that in UI we have page underscore 0, and inside that we have button underscore rect, and then what we have is button underscore rect, and then what we can do is we can say dot, let's say the height of it equals something, right? Now what we can do is we can get the current value of the height, and then we can reduce it, right? So we can get whatever the value is, and then we can minus, let's say 50 from it, or let's say 30 from it. And then we can say that if the state is 0, then we can write here plus 30, whatever the value is of the height at this point, add 30 back to it, right? So I hope that makes sense. So that's that. Oh, we have an extra equal here, my bad. So then we can simply run this, and by default you can see what happened here. If you click on it, there you go, nothing is happening. Why did we get this? So the height of it, the height of our rect, equals this dot height minus 30. So if the state is 1, we also need to change the X position of it as well, but I was hoping we can do the height first and then we can do the next part. So if we go to the UI and we go to page 0, here in page 0 we have on off button. Wait, what? Oh, this is a LED, my bad. We go to UI and we go to page 0, and here we have button rect, and the height of this is 59. Okay, okay. If it's 59 and then we reduce, oh, okay, okay, we can't do this. Okay, we cannot do this because this is running through a while loop, and every time we are getting an update, it's calling this function, and every time it's doing that, it's adding or reducing the value. Yeah, so that's the problem. So we cannot do that. Okay, so well, we can hard code it. It will be a little bit annoying, but it will work. So if we go to page 0 and we look at the height, it's 59, right? So we already know it's 59. So if the button is 1, it should not be 59. It should be 59 if the button is 0. And then what we can do is we can write here 59 minus 30, let's say. Yeah. So now it should go down. So if we are here and if I press the button, there you go. So now the height is being reduced, but the value of the Y is not. So we need to change the value of the Y as well. We need to bring it down. So by default, if we look at the value of Y, it's 124. So here we can write that the value of Y is 124. And if we press the button, then it should be minus 30. Or should it be plus 30? It should be plus 30. There you go. So if I press it now, there you go. Yeah, it goes way too far. So let's change that to 20 and 20. So if we come here, there you go. Yeah, that looks good. So let me show you the camera as well. So here, if I am pressing the button, there you go, it goes down. It looks pretty cool. So let me show you like this. So if I'm pressing the button, there you go, it's getting pressed there as well. Now if you wanted to change the color of it and do something else, you can do that too, because we already have the access of all this, so you can do that too. But yeah, that's the idea of this project. I hope you have enjoyed it, and let's move on to the next one. Let's discuss the hardware that we are going to use in this project. Now, like before, we have an Arduino Uno, and then we have our temperature and humidity sensor. So it's a very basic DH11 sensor, DHT11 sensor. You can see here we have VCC, we have data, and we have ground. So that's pretty much it. And all you have to do is you have to connect the VCC to 5 volts, ground to ground, and the data you have to connect to one of the pins. So what we are doing is we are connecting it to pin number 4, as you can see here. This is our pin number 4. There you go. And then here you can see we have the positive and the negative that goes to the breadboard, and from the breadboard we attach the positive and negative like we did before. So that's fairly simple how this is done. You can directly connect this as well without the breadboard because there's just 3 pins and there's no resistor involved. So you can directly connect it as well if you require that. So let's go ahead and look at the Arduino code. So here what we have is the DHT library, and then we have the CV zone library. So if you want to install this, you can simply go to the library part, and here you can write DHT sensor library, and here you will find from Adafruit, you are going to find this DHT sensor library by Adafruit, and you will go ahead and click on install. Once you install this, make sure you install with dependencies. So here it will ask you, do you want to install without or you want to install all? So you have to install all. So once that is done, you can simply define which pin number did you attach your DHT pin out. So that is pin number 4, and the type of DHT sensor. So we have 11. Then we are going to declare our DHT pin and type using our object. And then we are using the previous thing that we did, which was basically CV zone library. We are using that to send 2 values, and those values will be humidity and temperature. Then we are starting our serial begin. Oh, this should be serial data dot begin. So this is basically this over here, serial data dot begin 9600. Depending on which baud rate you want, we are using 9600. Then we have dht dot begin, and then we are simply getting the temperature reading by writing dht dot read temperature and dht dot read humidity, and then we are storing it in t and h. At element 0 and element 1 we are sending the integers of temperature and humidity, and here we are finally sending these values, and then we are adding a small delay. It's up to you how much delay do you want to add, and you can work around with that. So if we run this now, it will compile and done uploading. Then we can open the serial monitor, and here you can see this is our value, so 24 and 64. And if I, let's say, touch the sensor, the values should change a bit. There you go. So 24, 76, 75. So it seems the humidity is changing, the temperature not so much. Yeah, okay, so now it's 25. So that's the basic idea. Very simple code for the temperature sensor. This is something that you can readily find online, and it's very easy to use. So now let's go ahead and create our graphical interface that we are going to interact with to get our readings. So here I am in PyVisual, and we are going to start with our design. So here we can, for example, say weather dashboard. And now we are going to create some design. Now what we can do is we can create it like a news forecast kind of a screen where you have clouds and all that. Or what I was thinking is that we can create a design which replicates a thermometer, and then we can increase and decrease the temperature, when it increases and decreases the temperature, we can increase and decrease the mercury inside that, or the liquid inside that. So that will be kind of fun design. So let's go ahead and first of all change the width and height. So let's make it 300 and we'll click on fit. And yeah, I think that is fine. So once we have that, what we will try to do is we will try to do pretty much everything using circles and rectangles so that it's easy to follow along, right? So let's start with creating a thermometer, right? Something that is kind of circular from the bottom and edgy at the top. So here, let's make it a little bit thicker. So the border thickness, let's make it 4, 5, 6. I think 6 is good. And then we'll do the same for this border thickness. So far we have a rectangle and a circle. So then what we can do is we can reduce the size of this. This is how much? 100 by 100. So let's make this around 50 or maybe 60. Yeah, that seems better. And then we can move it a little bit at the top. There you go. So already it's trying to starting to look like a beaker or a temperature sensor or something like that. Okay, now what we can do is we can make this round at the top. So let's increase the corner radius to the max, and now we have something which looks better. There you go. And then what we can do is we need to remove these parts, so the black ones inside and this black one here. So what we can do is we can create another rectangle and we can remove the corner radius of it completely. We can actually calculate how much width do we need. So here we had like 60 and 6 is our border. So 6 here and 6 here is 12. So 12 minus 60 is basically 48. So we can write here that this will be 48. And then we can center it. And now what we can do is we can let's bring it down a little bit. And then what we can do is we can make this white. There you go. So now it's much better, and we can push this to the back. So yeah, so now it looks better. And then of course we can make this circle, we can make it white. Right now there's no color to it, so we can make it white and we can move it forward. There you go. So now this looks like what we were looking for. Now what we can do is we can add a little bit of liquid inside. So let's add a circle. This is 100 by 100. So we can make it, let's say 50 by 50. No, that's too small. Maybe 60 by 60. Maybe 70. 70 by 70. Yeah, I think that looks good. And then we can have another rectangle, which will be basically the upper liquid. So this part here was 48. Let's make this, yeah, let's make it 30 maybe. There you go. And let's remove the corner radius so it's flat. There you go. So now it looks good. And let's make the theme a little bit orangish. Now I do have the orange exact color that I want to use, so let's add that. So in the hex we can actually write the value, exact value, and this is the orange that we are looking for. So if we click on that, there you go. So now this is looking good. Okay, what's next? So then we are going to add some measurements on the side. So let's create another rectangle and let's make it, let's say 20 by 10. 10 is still too much. Maybe 8, maybe 5, maybe 6. I'm a little picky. Anyways, so let's select this. Why is it not getting selected? There you go. So then we can move it on the side and we can bring it down a little bit. And here we can make it black. So exact black. Yeah, that looks good. And then we need to replicate it. Now, in order to replicate, we don't have measurements to replicate exactly at the same distance. So what we can do is we can create a rectangle like this, and then we will reduce the corner radius, and whatever size we want, we will add it here. So for example, we'll give a distance of 20 in between. So here we will make it 20 and then we'll push it forward until it touches, and then we can copy paste and then put it here. There you go. Or maybe a little bit back. There you go. Now it's centered, so it's 20. So this way we can make sure that the distance between these is the same. There you go. And then we can put it here. Later on we will probably add some measurement where you can do this more easily rather than doing it this way. There you go. Let's add one more or two more. Let's put one here. Oh, didn't, it's not in the right place. There you go. Then let's do one more. So we will copy and paste. Okay, there you go. So now we have all of these evenly distributed. So what we can do is we can start from like 0, 10, 20, 30, 40, 50, something like that, right? So let's go ahead and add some text. So for text, I believe we can use user flow, and let's make it small, maybe like 12. No, smaller, 8. And then it is left aligned, which is good. And then we can make this smaller, and we can change the text color of this to something grayish, so it's light, you know, it should not be very prominent. And then we can center it here. Now we can write, for example, what was it, 50 C or 50 degree. Let's just write degree symbol. We can copy this, we can come back and paste. There you go. So that's 50. Then let's place one here. So there you go. So then we can change the numbers to 40, then 30, and 20, then 10, and then 0. There you go. And once that is done, let's fit it to screen. Once that is done, let's move all of this to a little bit in the center, or maybe a little bit lower than the center. Then we need a text which will display the actual temperature and the humidity. So for the temperature, we can use this color over here. Let's put a text again. Let's go to text, user flow, and let's make it like 32. Let's make it a little bit bigger. And then we can write here, let's say 32 degree Celsius. We can center it and put it like this. And then we can, what was the, okay, then we can change the color of it to the one that we copied. There you go. Now it looks good. And let's move this a little bit further down. Yeah. And then we can push this further down a bit. Okay. And what else? So then we also need the humidity. So humidity, let's put a design first. Thinking, let's make it a little bit different. What if we do something like this, and then decrease the transparency and push it back. And reduce the opacity to something like this. Yeah, I think that looks good. Okay, and then we can add the humidity. So for the humidity, we can copy this text and let's make it a little bit smaller, 24 maybe. And let's say this is 25%. Let's not make it, or let's make this bold. Let's make this bold. And this is not bold. Let's make this 22. And then we can write humidity below it. So here we will write humidity. And let's change the color of this to grayish. And let's reduce the size of it to maybe 16 or maybe 12. Now we can add an icon here as well if we'd like. Should we add? Maybe we should. Let's right align this, might look better. Yeah, I think right aligned looks a little bit better. Like that. What else? We can add some design here. Let's just copy this. And we can add design, a little bit of design here. Something like this. Maybe a little bit edgy. Maybe a little bit roundish. Yeah. And we can add an icon here. Any sort of graphics. Let's write weather and see what do we have. Okay, that's it. Weather is not good. So maybe temperature. I mean, yeah, we could add that. Or let's just search for icons and see if we find something useful. So again, you can pretty much add what you like, but let's say we add this, right? So based on your requirement, you can add your logo or something like that, you know, over here and make it white. There you go. Yeah, I think like that looks good. This color is not very good. Let's change that to dark gray. Yeah, now that makes more sense. So I believe that is pretty much it for our design. What do you think of this? I think this is pretty good. Simply using circles and rectangles to create something like this. And now what we can do is we can simply increase the size of this or decrease it based on the temperature. And then humidity, we can change the value over here as it is. Okay, one thing we didn't do is we didn't save yet, so we should save. We did a lot of work, and if we don't save, it might actually go away. So, and then let's go ahead and link it so that we can have it in our Python site. So we'll write here weather dash board, board, and select the folder, allow, and then we can update the UI again to sync it. So if we open up weather dashboard and then we go to app.py, here we have our code, and hopefully if we run this, and bada bim bada boom, there you go. So we have pretty much the exact same design that we built here. And if I just check from here, and you can match it to see if it's exactly the same or not. One thing you will see a little bit of difference is because this is at 86%, so we can click on 100% and we can go here and make sure it is 100% as well. So if both of them are 100%, then it should match exactly. So there you go. So as you can see, it does match exactly. This here needs to go down, you know, there it's scrollable because it's not fitting the whole window, but that's the idea, that it should perfectly match. Okay, so that being said, now we have our UI ready and we need to program it. So let's go on to the next part where we will start programming. Okay, so the programming part is fairly simple. What we have done earlier in our push button, we are going to replicate that. Earlier we had one button input coming in, but now we have two things coming in. One is the temperature and the other is the humidity. So what we can do is we can go to app.py here and app.py over here. We'll open both of them and then we will replicate. So we will be needing all of this. We will be needing threading, we'll be needing serial module like we had before, and then we will create our Arduino serial object. The toggle, we will discuss about that, but we will still copy it so that we can simply make changes here. And then in the attach events, we need to pool Arduino. So we are going to pool and we are going to start the threading part. There you go. So now looking at what we have here, we have pool Arduino, we are getting the data, and then once we get the data, we are sending it to toggle UI. Now instead of toggle UI, we can write here display underscore data, right? So it will be a little bit different. There you go, display data. So the data is being sent and the UI is also being sent. So it's very easy for us to work around with that. So in display data, we are getting the states using data 0. Now, if you remember in Arduino, we have the temperature and the humidity. So at 0, we will have the temperature, and at 1, we will have the humidity. So we should be getting both these values. So what we can do is we can print them out. So temperature and humidity, and let's run this to see if we are getting it. And there you go. So we are getting 2666. So like we did in Arduino, now we are getting the values in Python. Perfect. Now what we need to do is we simply need to place it on these values, right? We need to change this 32 and 25% to whatever value we are getting here. And that is very simple. All you have to do, you have to go back, and here we will make sure that we give it a variable name. So here we will change this to, for example, temperature underscore text and humidity underscore text. Right, so these are the two texts, and we can simply update it. We don't have to do anything else. And if we go back, now we can refer to them. Okay, so we don't need to check the states. So earlier we were checking what state it is, and based on that we were making some changes. We will not do it this time. Instead, what we will do is we are going to put our value and display it simply put. So here we can simply write, what did we name it? Temperature underscore text dot text equals whatever the text is. So let's say temperature, right? So let's see if we get that. And did it work? Doesn't seem to work. Okay, we will look into that. Let me just confirm that our naming has been changed. So if we go to page 0, I see that, yeah, there you go, temperature underscore text, and this is the text. So maybe we need to maybe we don't need to change it to integer, and we can simply give in the text as it is, and there you go. Yeah, that was the issue. So here now we are getting 25. Now what we will do is we will add to it, we will add plus whatever the value is plus this part. So we will copy this. What did I copy? So much stuff. Plus this. Okay, so we'll write the C and that in front of it. So wait, is that correct? 32. Okay, we might need to, no, I think it's not working. So okay, so what we can do, oh, there's a comma here, maybe that's the, no, probably not that issue. Let's check the print. Well, it is 25, so it is working. Yeah, there you go. If I keep rubbing it, I'm hoping the temperature will rise. So far, nothing. The humidity rises. Oh, there you go, 26, finally. Okay, yeah, so we can do the same thing to humidity, and we can write here humidity underscore text is our humidity plus percentage, so whatever value we are getting, and here we will change it to be a string and not an integer. So let's run that, and now you can see it's 61%. If I rub it, there you go, 66%, 68%, 70%. So as you can see, it's pretty live, right? So here is our temperature sensor. There you go, this is our temperature sensor, and here is our UI, which is being updated live. So if I rub this, you see this becomes 63, 65, and if I rub it a lot, it might actually change the temperature as well. So that's what I'm hoping for. So humidity is increasing, 68, 69, there you go, 27 degree, and it went back. So that's the basic idea of how we are getting the data from Arduino live into our UI, and the UI is being updated live. But the thing is, we haven't completed yet. Why? Because this part is not changing, right? So we need to change this value. So this should not be static, it should be moving. So we have the value from 0 to 50. So we need to check when is it at 0 and when is it at 50. And then we need to find the actual value of that, right? So we can go back to our UI here. If we reduce it down to, let's say, 0, this is our 0 value, something like that. Then our position we need to check. So if we click on the code, let's change the name of it first. So this is our moving rect. Okay, so let's save it like that. And then if we go to the code UI page 0, we go to moving rect. So our position is 127 and 246, and the height is 38. We need to increase the height of this, and we need to decrease the y accordingly. So these are the two values that we need to change. So by default, 38 and 246 is where it is at 0. So if I go back, I will write it down here that our 0 is y is 240, what was it, 6, 246, and our height is 38. So this is at 0 position. At 50, now we need to check what is the value at 50. So if I go and push it up, there you go. And if we go back and check now, moving rect, the height is 170 and y is 114. Y is 114 and the height is 170. The height is 170. So if we subtract 170 by 38, we get 132, right? So this is the change that we are getting. So this is the maximum value, the maximum increase. And this here, the change is, how much is that? 244 minus 114 is around 130. So it's pretty much the same. So if we are changing 132 here, we will change y with the same value. So we don't need to worry about both of these. We just need to worry about one of them. So now what happens is that we need to go back, and at zero, we are getting the value of what is it? At 0, we are getting the value of height as 38, right? And then at full 50 degrees, we are getting the value of 170, right? So these are the two variations. So 38 and 170, that's the minimum and maximum. Now, another way to put this is that we can say our starting value is 132. No, our starting value is 38, and whatever changes we make will be on to this. We will be added to it. So the maximum we can do is 132. So 38 plus 132. So this is the approach we are going to take. So our initial value, so we are going to copy this part and basically this one, the height. Okay, so here we will say that our moving underscore rect dot height is 38 plus whatever the value of our temperature is, and then we will add it here based on the value. So we need to constrain our value of temperature from 0 to 50. And based on that, we are going to multiply that with 132. So here we will write that temperature divided by 50 multiplied by 132. I hope that is correct maths. I'm just doing from the top of my head. Okay, so what are we getting? Oh, we got a huge height. So the height is this, but then of course we need to change the value of the y as well. So let's just print this. So print, and we can call this the change equals this, and then we can write here change. Let's print it out and see what do we get. Invalid syntax. Where is the invalid syntax? My bad. Let's print the change. Wait, it's not printing anything? Why is that? Let's run it again. So why wouldn't it print the change? So as you can see, it's printing here. Then when we come here, it's not printing. So what if I do this? Still not printing. Let's print hello, and there you go, we are getting hello. So probably the issue is here. Okay, so whatever the temperature, oh, the temperature is is not an integer, that's why. So now it should work. Wow, sometimes you get the weird stuff. There you go. So here we are getting, let's remove this, let's run it again. There you go, 60.72. So that is the height, and there you go, this is what you are getting right now. But of course we did not add it here, so we need to add it here. So we can write here that our change is this, and then plus change. There you go. And of course we need to change the height as well, so that is important. So the moving rect height, by default it was what, 244 minus the change, or is it plus? Let's try minus. No, it's not minus. Okay, so something weird is happening again. Oh yeah, sorry, my bad. So the y should be this, and it should be minus. Okay, there you go. Working now. So yeah, that's the idea. So if if it were to dramatically increase, then yeah, it would shift up and down. We could do it for humidity, right? So because that will change quite a bit. So let's try it with humidity, and then later on we can revert it back, right? So let's put humidity, and let's put 100 here, and then run it. So right now the humidity is 64, 63%. If I rub this, just need to see, yeah, there you go, that our temperature is rising. Yeah, it's not the temperature, but it's the humidity that's rising. So as you can see, it actually reflects on that as well. So yeah, so you can, because it's 100%, so you put it back to this 50, and what was this temperature? There you go. So that's basically our idea. It looks pretty good. The design is good. So let me run it one more time. So here we have our temperature sensor that is sending direct signals to our UI, and it is being updated live. So the temperature is a little bit harder to change, but the humidity is easier. So if I rub this, the humidity should go up. There you go, 62%, 69, 72%, and hopefully the temperature rises as well. There you go, 25. And as you can see, this bar also went up. So the liquid inside the thermometer actually moved up as well. So it's not just static, it actually moves around. So depending on the value, it moves up and down. So that's basically the idea of this project. Whatever values we are getting, we are displaying them on our beautiful modern looking UI. And that's the whole point of this project, that we create stuff with Arduino, but it should be presentable as well. Something like this, and all of this is done using our drag and drop interface. So if I wanted to change, I could bring my temperature right now here, and if I update it, this will update in real time. And if I go back and rerun it, then my UI has been changed. And not only did it change, it's still working condition. So if I rub it again, the temperature value will change. It will still work even though we have changed its position. We have changed the UI a bit. There you go. So that's the beauty of Pi Visual and creating UIs with this, that whatever design you want, you can drag and drop. And all of this we created using simple squares and circles. That's it. No fancy icons, no nothing. Only this part was an icon. The rest of it, all of it, is simple, basic shape, rectangle and circle. That's it. So this is it for this project. I hope you have learned something new, something exciting. And as a challenge, I would like to give you something that you can add 2 boxes here, and you can display the minimum and the maximum the temperature has gone since you started. And you can do the same for humidity. So you can add more information to this. And then you can even send this data, you can store it in a database like MongoDB, MySQL, and so on. And all of this we will be explaining, and we will be teaching you in our premium course, which is the next part of this. This was the basic version, then we have advanced, and then we have pro, in which we have lots of different projects which give you the UI and the code for it as well, and it explains how exactly can you make all of this. So it is very helpful if you are creating some creative UIs or enhancing your skill set to improve your graphical ideas, because making software is good, but making modern software is the key right now. You should have some good design, some presentable designs to actually go forward with your projects. So this is it. I hope you will go and check it out. If you think that is good for you, it will be listed at a good price for a few more days, so you can check it out. And after it launches, right now it's available for pre-order. After it launches, the prices will increase, so you can go ahead and check it out and enhance your projects and learn something new. And if you enjoyed this video, give it a thumbs up and share it with your friends, and I will see you in the next one.